What up, people? I'm in this house, and this is what we're doing today. We're going to talk about angle relationships in triangles. Okay, we're going to talk about how to find measures of the interior and exterior angles of all triangles. First, you need to know the triangle sum theorem, which means basically that all the inside angles add up to equal 180 degrees. So A plus B plus C, they all equal 180 degrees. Okay, so let's look at an application of the triangle sum theorem, okay? So let's do this. Let's find the angle measurement. So let's find the measurement of angle W, or let's do X, Y, Z first. Okay, so if I want to find the measurement of this angle right here, X, Y, Z, I have this triangle right here. What I'm going to do is I'm going to add 62 and 40 together. I'm going to subtract that from 180, and that should give me the degree of that measurement of that angle. This one then would be 78 degrees because all of those add up to equal 180. If we take it a step further and we try to find the measurement of angle YWZ, this angle right here, I can take this whole angle now and understand I'm looking for the red. I can take this whole angle right here and add that together. So 78 plus 12 plus 40 and subtract that from 180 and I should get 50 degrees. So that makes that angle 50 degrees. So that's how the angle sum relationship comes into play. Alright, so what I want to do is I want to talk about two corollaries. A corollary is something that comes straight from another proof. So like I prove something's true and then I can create another proof from that proof, and so that's a corollary. And these both come from the triangle sum theorem. Real quick, these are easy. The acute angles of right triangles are complementary. Well, that means that they equal 90. And the measure of every angle in an equal angular triangle is 60. Again, that means all of these are 60. So these equal 90, these equal 60. All right, so let's look at a quick example. One of the two acute angles in a right triangle equals 2x. What's the measure of the other one? Well, remember they're complementary in a right triangle, so all I do is do 90 minus 2x. And if you remember, we did this before back in chapter 1, so that's the answer. So your other angle is 90 minus whatever 2x is. You're not going to solve for x, you're just saying 90 minus 2x. Again, if you have a measure of another acute angle that's 63.7, then all you do is 90 minus 63.7, which is 26.3. So that's what's going to make my other acute angle. Okay, let's talk about triangles and their interior and exterior. So I can draw a triangle, and the inside is the interior, obviously. Okay, and the outside is the exterior. So that means that when I connect and create larger segments that come off of this, I can create an angle that comes out right here. Let's call this angle 4. If I call that angle 4, this is known as an exterior angle. Okay? So let's go ahead and just label all of these 1, 2, and 3. So 1, 2, and 3 are interior angles, and 4 is an exterior angle. All right, when we take a look at this, there's a theorem that comes into play, and it's the exterior angle theorem, which I'm going to show you in a second. But the way it works is this. If I take this angle right here, and I add it to this angle right here, it's going to equal this exterior angle out here. Okay? So again, if I add this one and this one together, it's going to give me this angle out here. And the whole reason kind of comes about through this linear pair right here, this 3 and 4. But I'm not going to really go into that much right now. I just want you to understand that if I take and add these two angles together, it's going to give me this third angle, which is the exterior angle. Right now, you need to understand that these two angles are called remote, like remote control, interior. So those are remote interior angles. These are the angles that are not beside the exterior angle that I'm looking at. Okay? They're not beside it. So 3 is just an interior angle. It doesn't have a name. Okay, so the exterior angle theorem this theorem is when I have any exterior angle coming from a triangle. We can call it 4 again, that'd be fine. Let's make this 3, 2, and 1. It's whenever I add the two remote interior angles together to equal the outside angle. Again, those are the angles that are not beside that angle. So 3 and 2 are the remote interior angles. So if I take the measurement of angle 3 and I add that to the measurement of angle 2, it's going to equal the measurement of angle 4 all the time, every time. Okay, this is something you need to write in your notes. You need to know this theorem. Okay, so what I want to do real quick is I want to apply this exterior angle theorem real quick to find the measurement of angle B. So to find the measurement of angle B, I know that A and B are both remote interior angles, and if I add them together through the exterior angle theorem, it should equal 5x minus 60. So to find angle B, I have to actually find x first. So I'm going to set up an equation where 15 plus 2x plus 3 equals 5x minus 60. Okay, so now I got this equation. Let's just go ahead and solve it. It's real easy. So you got 15 and 3 make 18 plus 2x equals 5x minus 60. Okay, so I'm going to take my x's to one side, numbers to the other. You're going to subtract 5x, and you're going to still have 18, and you're going to have minus 3x equals negative 60. You're going to subtract 18 from both sides. You're going to have negative 3x equals negative 78. Now, you're going to divide negative 78 into negative 3, and you're going to get 26. So x is going to equal 26. But that's not your answer, because you need to make sure you're trying to plug it back in to find b, right? So what you want to do is you want to plug that back in, take 26 times 2, okay, and you get 52, and then you add 3 to that. So you got 26 times 2, and you add 3 to that, and you get 55. So we have a 55-degree angle. I can plug x back into here and find this angle as well if I wanted to. Okay, so we're going to do the same thing. We're going to find the measurement of angle ACD, which is this angle right here. To do that, I have to add the two remote interior. Again, those are the angles that are not beside the exterior angle. So I'm going to add those two, and I'm going to set them equal to the outside one. So what I have is I have 2z plus 1 plus 90 equals 6z minus 9. All right, I'm going to combine like terms, and I have 2z plus 91 equals 6z minus 9. I'm going to subtract 2z, and I'm going to add 9. And what's going to happen is I'm going to have 100 equals 4z, which makes z equal to 25. But again, I'm not done. I got to make sure I find the angle that I'm looking for, so I plug that back in. And so I do 25 times 6 minus 9, and that angle should be 141 degrees. So basically, you need to make sure that you understand that I'm adding the two remote interior to equal the outside angle. All right, last but not least, very easy theorem is the third angles theorem. And we're going to need to remember this one. You need to chalk it up and remember it. What are you going to do? Remember the theorem. Remember it. Put it in here, right here, right here. And it's simple. It says if you got two triangles that have two pairs of congruent angles, then that means that this last angle has to be congruent to this one. And that all comes from the triangle sum theorem that says that all the angles have to equal 180. So that means these other two angles have to be congruent. All right, let's look at our last example then for the evening, applying the third angles theorem. Since n is congruent to s and m is congruent to r, that means we know that p has to be congruent to t. It means if they're congruent, they have the same measurement. So if they have the same measurement, that means I can set these two things equal to one another. So all I'm going to do is do 2x squared equals 4x squared minus 32. If you look, we're trying to find the measurement of angle P and angle T. So we're going to find them both. Now, they should be equal, okay? So you got to find x in order to do that. So we're going to subtract 4x squared from both sides. And we're going to get negative 2x squared equals negative 32. Divide by negative 2, you get x squared equals 16. Alright, so I have x squared equal to 16. So I don't have to solve for x because I know what x squared is, so I can just take that and I can plug it back up in there where x squared is. Or I could solve for x and plug it back in. But if I plug 16 back into where I see x squared, that means I'm just going to take 2 times 16 because x squared is the variable, right? So 2 times 16 is 32. And if you plug it in here, you'll get 32 degrees as well. But let's take it a step further real quick and make sure you understand how to solve for x if you need to. Since it's being squared, it's just like the Pythagorean theorem. To undo this, you have to square root. And so x actually equals 4. So in geometry, we only care about that 4, not the negative 4 that it produces too. So x equals 4, x squared equals 16. Okay, so there was a lot of information, a lot of stuff going into your head. But one thing that you need to remember is that all the interior angles in a triangle equal 180. And everything kind of comes from that. If you can remember that, then you can always usually remember all this other stuff that goes with it. The third angles theorem, the exterior angle theorem, okay? The two corollaries that we talked about, that the acute angles in a right triangle are complementary and that all angles inside of an equal angular triangle are 60 degrees. Just try to put all of those together and we'll talk about that more, okay? So let me know if you need anything, okay? And have a great evening.